All right, we'll go ahead and get started. My name is Chris Wilson, and I'm with GoEngineer. Just wanted to thank everybody for joining our digital manufacturing seminar for 2020. I'm coming to you live today from our Sacramento, California location. Joining with me are some of our top application engineers, most of whom are based in our Salt Lake City, Utah location. This team includes Tyler Reed, Cameron Bevan, William Huertas, and Tate Brown. GoEngineer provides design and manufacturing tools with the expertise that is enabling our customers to greatly reduce the cost, risk, and time required to go live with new technologies and new product development. If you look on the right, you can see a vast list of the hardware and software that we offer to our customers. One of the largest product offerings is Solidworks and the suite of tools that come with that, including the PDM, simulation, SolidWorks Manage, and even CamWorks for CNC machining. But for this event, we're going to focus on the Stratasys 3D printing, primarily the PolyJet and FDM, and the handheld scanners from Creaform, and of course the DesignX and ControlX software from GeoMagics. A little bit about who we are. 40% of our nearly 300 employees are certified technical specialists, delivering technical support, training, and application expertise. Over 95% of our customers do repeat business with us, and our longest relationships span over 3 decades. GoEngineer is the 2019 #1 global partner for both SolidWorks and Stratasys. What does that mean to you? A vast array of resources to pull from to help ensure your success. We've got over 25 offices across 14 states and growing year over year. All of our hardware and software is backed by world-class technical support. The hardware and software is also backed with training. We're offering training for all this technology either virtually or in person when applicable. We're also offering a wide suite of advanced manufacturing services, whether this be 3D printing services, 3D scanning, all the way up to low volume CNC machining, casting, assembly, anything to take your concept all the way through low volume prototyping. Now I'd like to kick this off with the Creaform HandyScan Black Elite demo. I'm going to hand it over to Cameron Bevan now, who's going to take it from here.
All right. When I talk to people about 3D scanning, I like to first explain that it's really a 2-part process. The first part is the scanner, the hardware, where you're going to actually capture the scan. The next part is what you're going to do with that scan. Are you going to reverse engineer it? Are you going to inspect it and take measurements? These are the things we need to know about so that we use the right tools for that process. We're going to break it up into those 2 halves. And I'm going to focus on showing you the first part of that process, which is capturing the scan. Then I'm going to hand off to my buddy William, who's going to show you some reverse engineering and inspection with that scan. So first, capturing the scan. Let's look at the 3D scanner. What I have here is the Creaform HandyScan Black Elite. This scanner is handheld. It's connected only to my computer by a USB cable. So I have pretty free to move around. I have mobility and it's very lightweight, and to be honest, it's actually really easy to use. So with this, you're able to capture very detailed, precise scans, get really great data, and then pass that down the line to that next part of the process. I already have it plugged in, and I've already run a quick calibration. So let me show you a little bit about the scanning process. First of all, because this scanner is not hard mounted with an XYZ axis, it needs to know where it is in space. And that's done by putting targets on the part that you're going to 3D scan. So for instance, if my part is large enough, I might just put targets on the part. And that will allow me to scan the part. And as you can see, the part can move. The part does not have to stay static, does not have to be hard mounted, because everything is moving together. So it can be a really great option for scanning things out in the field, scanning larger items that you can't get back to a clean room and hard mount. Now, let's say I'm going to scan something that is smaller and I want to do something more precise. What I have here is a turntable that's already pre-targeted. I have a little, we call it a shark fin. It's actually a disc brake guard for a motorcycle. I'm just going to set it here, and I've got targets in the background. I'm going to do the same thing. I go to scan, and as I'm scanning, you can see on the screen behind me, or maybe live on the part, there's actually an 11 laser cross-section that's going over the part, and every time those lasers go over the part, the cameras see that. It's able to pick up that data very quickly, very precisely. Now, I've got a lot of extra stuff in the scan that I don't necessarily need. Well, we have the ability to do things like add a clipping plane. So I can come in very quickly, select a few targets here on my screen, and it immediately gives me a plane that I can select and say, okay, yeah, let's delete that. So now all of that background data is deleted. I also have the ability to do things like grab the geometry of my part, and then quickly select everything else in the scan and delete that very quickly, which leaves me with just a clean version of my part. If I want to go back to scan mode now and rescan and get a little bit more data, I can absolutely do that. I can zoom in right here from the handheld to get a little closer up and show detail. I can also switch to a single laser mode, which allows me to focus in on specific areas and get really precise detail down in a hole, down in a cavity, something like that. The single laser mode has a little bit better point of view. Now, you might be asking, well, what about on the small part? How would I get the other side? Well, once I have the data I want from this side of the scan, I'm simply going to flip the part over. I'll come in here to my software and just tell it to add a scan. And I don't know if you can see it on the screen, but over here I have a little bit of a feature tree. I have my scan 1, and now it's just added scan number 2. And all of the same features came over. So I'm just going to turn off scan 1 so it's not in my way. It's already given me that clipping plane, the targets, everything's right there. So I'm just going to go ahead and hit scan. Oh, started on the single laser mode. And there it is, starting to scan the second part of the part. I'm going to work myself around it. I like to compare it to a paint gun. If you haven't painted that side of the part, you don't have data there yet. But as soon as you go over that, you're going to have data. It's going to be nice, crisp, clean, and I probably didn't mention it, but this scanner on a part like this will hold just about a half thou accuracy. So it's very accurate. Once I have all the data I want, I'm going to go ahead and stop that scan. Then I'll come up here in the software, and I can clean it up now, or I can leave it the way it is. I'm going to come over here to merge scans, which is going to give me a screen where I can either try to automatically put them together or put them on a split screen like this, where I can get them into the same attitude, pick common points between them, and then just mesh those two together. So this way, I'm getting a complete scan of the part all the way around on a smaller part. As you remember, on this larger one that I showed at first, if I can target the part, well, I can either have that sitting down, flip it, as soon as it sees the targets, it scans all the way around. So you have a lot of freedom in using the targets. You're not confined to a mounted location. And you can get a lot of great scan data really quickly. Now, after I go through this process, on some parts it might take 2 scans, maybe 3 scans, maybe even a 4th scan. You can go ahead and do that. But what you want to remember is that once you put those together, you're going to get a complete scan that you're going to export over to your next part of the process. Now, I mentioned I was going to turn that over to William. So I believe William has actually this same part queued up, and that's where we're going to be moving here in just a minute. So to finish up this part of the scan, all I would do is finish putting this together, go up here to the file, go right to export, kick that out as an STL, which would be a mesh model, and then we would move that downstream to one of our 3D scanning softwares. Now, I get asked all the time, can I throw that scan straight in Solidworks? The quick answer to that is no. Solidworks does not like to work with 3D scan models. And you might say, oh, well, I have all these mesh tools. Yes, you do, but chances are the type of mesh that's going to be put out by a modern 3D scanner will not be able to open there in Solidworks with anything other than just like a 3D image. You probably won't be able to select it, create anything. And so you really need a 3D scanning software to bridge that gap. What we recommend, and one of the products that we have a lot of success with, is GeoMagic. GeoMagic has a number of different tools for both reverse engineering and for inspection. And that's what I'm going to do now, is actually kick this over the fence to William so that he can go ahead and show you the next step. And so he's going to start with a mesh model of this part and to show you exactly everything he would do to, I believe, both reverse engineer it and do a quick inspection on it. Thanks for letting me show you that today, and we'll go over to William.
Thanks, Cameron. So as you mentioned, bringing STL files into SolidWorks isn't really, although we do have mesh tools and we have things like Scan to 3D in SolidWorks, it's not really designed to be a full reverse engineering software, as you mentioned. So what I'd like to show today is GeoMagic DesignX. So this is a very, very cool product. The really unique thing about this software is that it's a reverse engineering software, but it's also a full CAD software. And the really cool thing about the CAD portion of this software is that it's closely modeled after SolidWorks. So you'll see, if I go to, the model tab, for example, of this software, you'll see names like extrude, revolve, loft, sweep. You'll see a lot of the tools that you find in SolidWorks inside of this software, DesignX. So it's really cool because it brings to the table that you have the full reverse engineering capabilities, but also full CAD capabilities as well. So if you're a SolidWorks user, this software is very easy to pick up. So the learning curve is very good on this particular software. So as Cameron mentioned, I have here the actual merged file that he did. So he did that in VX Element. So I have this file here. Very, very good scan. However, this part was actually in use. So you'll see some differences once I'm done reverse engineering this, and then I'm going to bring it into Control-X to show you some of those major differences and actually get dimensions. So let's go ahead and get started. One of the first things you'll notice about scan files from pretty much any 3D scanning software is that the origin, depending on where you have this scan completed, for example, Cameron put targets on a table or on a wall, usually the origin of the scan is out in space. So I'm going to turn on my front, top, and right plane just to show you that this scan is in fact kind of floating out in space, which is not a big deal because in DesignX, we can actually align that very, very easily. In fact, DesignX has some very unique tools that help you do that very quick. So I'm going to hide those planes just for a second. And this software has something called regions. So in other software, you may have to manually create a lot of planes, cylinders, cones, things of that nature to help you do this kind of operation. GeoMagic DesignX has something called regions, and they're called region groups. So I'm going to use my Smart Select tool and show you exactly what it does. So using the Smart Select tool, I can click on a triangle and move my mouse up or down, and the software will grab similar points or triangles that have a similar normal, and I'm able to actually create a region group. So I'll go back to my Home tab here, and I'll say Insert a Region. So it'll change color on the mesh, and I'm just going to hover over it just to show you. The software has now classified that group, that region group, as a plane. So I can use that to help me align the part. Now, I need 3 entities. So the reason I need 3 is I want to go ahead and align all 3 degrees of freedom to the origin. So I just need 3. I can have more if I want to, but 3 is enough because there's 3 degrees of freedom to align this to the origin. And it's very important that I do this first before any reverse engineering, any sketches, any extrusions, because I'm going to transfer this to Solidworks. So I need to make sure that this is on the origin. So when I transfer it to Solidworks, I can continue to work with it from that same origin. So I got that region there. I want my second region here to be a cylinder. So I'm going to use my Smart Select tool once again, and I'm going to click on Insert. And if I hover over that area, you'll see that that's a cylinder. So the software is classifying these areas as specific geometric entities, right? So I'm going to go ahead and make my last one. So I'll make this plane here, this area, a plane region. And it's very quick, it's very easy. If I hover over it, you'll see that that's also a plane. So that's literally all I need to align this part to the origin. So there's this tool called Interactive Alignment. I'll hit the next stage. And this is very, very cool because on the left side, I have like just my standard view. And then on the right side of the screen here, I have a preview. So while I start selecting stuff, I can actually see what I'm doing and get a preview of my alignment. So for the origin, I'd like that to be the position. And I'm going to click on that planar region and also that cylindrical region and tell the software the intersection of those 2 entities should be the origin. And if I look at the right side, you'll see that, I mean, it's not perfectly aligned yet, but you'll see the origin is kind of where I want it. So my z-axis will be that same bottom plane. And finally, I'll select my y-axis to be that last plane region that I have. And you get this preview here, and the origin is not quite where I want it because I can switch my, my normal for these planes. And finally, this looks the way I want, and I can always double check by using my standard views like front view. I can click on right view or top view, and that looks exactly how I want. It's very simple, very quick way to do that. And once I'm done, I just go ahead and accept that. And if I turn on my standard planes, the software actually moved the scan to where I wanted it, right at the origin. So if you look here, the origin is exactly where I want it inside of that cylinder. And obviously using the other 2 entities as a guide, this is exactly where I want it. So from here, I can just start doing my standard reverse engineering practices and get this thing fully reverse engineered. So the first step is I usually make a copy. You can see here on my feature tree, I made a copy of the mesh. Usually I do that just in case I do something to the mesh. Maybe I filled in a hole I didn't want to. I always want to be able to refer back to the original scan. So I always make a copy of it. So I'll hide the planes for a second. I don't need to quite see them right now. And one of the cool things that you can do apart from making copies of the mesh is making separate region groups. So one thing I did with the copy of the mesh is I made separate region groups because I'm going to need to know when I make the extrusions how far to extrude, right? Like how high in terms of like a dimension. So I could measure stuff manually, or you're going to see in a second how easy it is to use DesignX to actually just go up to the region and get the exact value that you want for your extrusion. So that's why you see the green, the orange. I just made a separate region group for those areas. So it's very simple from here. The first thing you want to do is start creating your sketches. So in this software, they're called mesh sketches, but it's just a cross section. Let me show you how that works. So essentially, you pick a plane, a base plane. In this instance, it'll be the bottom of the part, which I align to the front plane. So I use the front plane as my base, and I can grab that. And I have this little arrow here where I can tell the software to intersect the part, and you see a blue preview here. So wherever you see the blue line, that's what the software is going to give you in terms of a cross section. And the really cool thing about DesignX is, I'm going to zoom in so you can see, is no matter where I have, no matter what height I have that cross section at, it'll project. That's why you see the dotted blue lines here at the bottom. It'll project it to my base plane. So that makes things very quick for you to just start making your sketches and your extrusions no matter how high. Because there's some other software that, for example, right now I'm at 1 inch high. It'll actually make your cross section at 1 inch. So you'd have to project that later on in the process, where here in DesignX, it's just that much faster. It already projects it for you, and you're ready to go. So I'll hit the X on that. Let me show you what a sketch looks like. So this particular sketch, my first sketch is completed, but I want to show you something. So this pink line sketch is my cross-section. They call it a polyline sketch. And really all it is basically just a composition of geometry from the mesh. So it's not perfect. Circles don't look perfectly circular. Lines don't look perfectly linear because it's from the mesh, right? So it's your job to manually go in here and trace over it. In other software, that's a very long process. I can show you here, DesignX, Geomagic DesignX has this very unique tool called Auto Sketch. So you might think that a sketch like this might take somebody, I don't know, maybe 15, 20 minutes, maybe more. Usually ask my students how long it'd take them to sketch something like this, and they usually say about 20 to 30 minutes, and that sounds about right. Well, using the Auto Sketch tool in DesignX, it's only available in DesignX, I can literally just hover over this entire sketch, and you see all the blue lines, and in a second, I have all of those entities already drawn there for me. Apart from that, it also added sketch relations. So you SolidWorks users might see tangency, perpendicular, vertical, horizontal. All those sketch relations got added for me automatically. Now, it's not 100% perfect. You still might have to go in there and change some of this, but it's a lot faster, I would say, just so much faster than doing this manually with other reverse engineering software. So, and there's also a resolution grab bar here that I can grab if I want less tangency, if I want more tangency, and you'll kind of see the preview change a little bit. But that's completely up to you. You can go in there and change stuff. You can even remove small fillets if you want to. It's a very, very easy thing to do. And I actually didn't have the entire sketch drawn. You'll see in a second. I just have the outer profile because I always teach my students extrusions go first, then cuts. I teach SolidWorks, and that's one of the main things that I always repeat every day to them is extrusions go first, then cuts. And if you do that, you follow that rule, your designs will be a lot easier to modify. So once I have that sketch, I can extrude that, and I have my very first parametric feature. So this is no longer a mesh, 100% parametric data. So from here, I can just go ahead and start the same process. Like from here, it's repetitive. I get another cross section, and I make another extrusion. So there's my other one, and then I have one at the top, right? So I use the same exact method that I've been doing, and I grab another cross section for that top area, and I do another extrusion. Now, you might be wondering, well, hey, William, how do you get those extrusions, right? Like, how do you know how high to go, right? Well, it's a very simple tool. When you use the extrusion tool, and I turn on the mesh, it's very cool because I can actually snap, and you can see when I'm grabbing my extrusion, I just get close to the region and it snaps. So I zoomed in so you guys could see that like the boundary of that region lights up and you can snap to it. So it's a very easy thing, and regions help you do that so much faster than having to go in there and manually measure this stuff. So it's very, very easy. That's a very, very unique tool to DesignX is the regions, and that's what allows me to get all of these extrusions. And then the very last thing was I needed to create a couple cuts. So I'll go ahead, and I got a cross section for that in all the inside cuts, and just like in SolidWorks, I do a nice extrude through both directions, extrude cut, and that's done except for this slot cut here. Now for that particular area, I really just needed the information for this inside slant area. So I got a cross section for that. And I just used a little box using the same method. I just went up to the other region. In fact, if I rotate the part, you'll see that I have another planar region where I could do the same method I was doing earlier. And, okay. Okay, so, yeah, so the last thing I want to do is do that cut. And if you look here, I have the last cut done. Exit this sketch. And finally, I can show you my completed, fully reverse engineered part. So this part here is 100% done. Now, other software can get you to this point. This is where things change. Usually, other software can get you to this point. You have just a solid body that you can import into SolidWorks. Now, that particular solid body may not have the actual feature tree and all of the features involved with it. So DesignX has a very unique feature called live transfer. So it's actually very, very easy to use. You just click on the live transfer tool here, and all of the feature tree, including my sketches, my extrusions, all of that will get transferred into SolidWorks, kind of like a movie. If I turn it on in a second, you'll see. So I'll click the check mark here, and I can switch over to SolidWorks, and kind of like a movie, you'll see all of my sketches, my planes, my extrusions, my cuts, all of that gets brought in very slowly. And it'll take about a minute or so to get all of that in there, but you can see that I have parallelism, just parallel, tangency, any other sketch relations that I have get transferred with it. I'll hit OK. I'll hide the planes there, and 100% everything that I did in DesignX has now been transferred into SolidWorks. And this makes the tool very unique because there's no other software that can really do it to this level. And obviously the biggest reason to have this inside of SolidWorks is you can just point it here into any of these sketches. And just like if you had done this in SolidWorks to begin with, you can right click, edit a sketch, and obviously add dimensions, or, at this point, the sky's the limit. You can, make drawings, you can use this part as part of an assembly, so on and so forth. So at this point, it's pretty much 100% done, and you have all of the data that you had from DesignX inside of SolidWorks. Okay. Okay. So the next thing I'm going to do is transfer to ControlX. So what I'm going to do is show you how to inspect. So this is a scan to inspection software. And what this software does, actually, give me 1 second, Okay, sorry about that. So this is GeoMagick ControlX. It's the brother software of GeoMagick DesignX. And the whole purpose of this software is to basically, get a scan file and inspect it to an original CAD. In fact, you can actually inspect this, you can actually inspect scan data to other scan data or another mesh. So you don't actually need a solid body to run an inspection on a scan file. But for this particular case, I did actually have a solid body. So I want to show you the process of inspecting a part to CAD using the model that I had from SolidWorks. So yeah, so this is a very, very simple software. You might be wondering, when would I want to use this? Well, there's a variety of reasons you'd want to use a scan to inspection software. For example, if there's a part on a CNC machine that you want to inspect a curve, and you don't want to take it out of the CNC machine, you can actually use that scanner that Cameron was showing earlier, the HandyScan Black Elite, and do what we call in-process inspection, where you can actually scan that surface and bring it into here, and you already have the CAD model, right? So you can do a very, very quick inspection on that surface if you notice that something was wrong with it, maybe. You can get a color map for it and check it really fast. So there's a variety of different reasons. For this particular case, let's say this was a first article. Let's say I'm going to remanufacture this brake guard, right? And a company sent me the first article, and I scanned it to take a look at it. Using this type of scan to inspection is very, very quick compared to like using manual calipers, so on and so forth. And it brings to the table that you have a lot of those tools that you might see in other software here, and it's a lot easier and quicker to use. So without further ado, I just want to show you how to do a quick inspection here. So like before, the scan file is actually, floating in space. There's my CAD model, which is aligned to the origin. I'm going to do my initial alignment. It's a very quick, just kind of, I don't want to say rough because it's actually not a rough alignment. It actually, with the initial alignment, it got really, really close, but it's just kind of to get the scan file close to the model. There's a bunch of different ways to align to the CAD model, but if you want to get something tighter and more accurate, you can use a best fit, and you can even specify how much of the data you want to use. I'll just go ahead and use 25%, and you can see that that's now fully aligned to the CAD model. So this makes things easy to start doing my inspection. So one of the first things that people do when they're doing this kind of scan to inspection process is create what people call a color map Some people call it a heat map, a deviation map. It's just there to show you the deviation between the scan file and the CAD model. So I'm going to go ahead and just show you really quick. I can click on the tool, 3D compare, and I can do this for the shape or the thickness. It's pretty cool. And I'll hit the next stage, and you get a preview of it. So you can see here, you can set your tolerance for the bar and for your actual tolerance of the model. You can set that and you get a nice color map. And it's very cool. You can add whiskers if you want to, add separation. So you can show the contour lines of where deviations exist in the part. There's a lot of different things you can do with this tool. Very, very interesting. If you're interested in specific areas, you can create what we call comparison tags. And essentially, you can just come in here and add a few of these points if there's specific locations that you want to check, and those will be color-coded and show deviation as well. So you can do a 3D compare. You can also do that in 2D if you wanted to. I can click on the 2D compare tool, and it creates like a sort of like a, it's not really a cross-section. It's checking the profile of a part. So I can come in here and like around at 1.6, tell the software, I want to look at that profile. And there it is, the profile in 2D, and same thing, I can just go in here and make some comparison points, just like before. And if I'm interested in specific locations, okay. And yeah, so I can do 3D compares, 2D compares, and I can hide and show anything I want to here on the feature tree. So anything that you do in this whole inspection process is recorded. So let's say I had, I'm scanning this to inspect my first article. But when they send me the 500 parts that I want, like maybe every 50 parts or every 100 parts, I can use this same inspection process for all those other scans. It's called batch process. I wouldn't have to do this 20 or 30 times. I just do this whole inspection process one time. The software records everything, and I can just use batch process to do the inspection for all 50 or 60 parts. Okay. All right. So those are the just 3D kind of comparison, color map type of things. But one thing that everybody wants to see is, how do I make dimensions, right? Like, how do I, bring in my GD&T, my, parallelism, perpendicularity, flatness, so on and so forth, right? So first of all, if you wanted to do that kind of stuff, you'd need datums. So I can create groups of dimensions. So the first thing I'll do is specify what my datums are. So I can say this bottom area here is datum A, the cylinder here, datum B, and then that plane there, datum C. And I just created a group there. I can rename it if I want to. I'm not going to right now. I can add a second group, and I can say, if I want to make dimensions, usually the way I do it is I'll go to like front, top, right view, and do my dimensions that way. So I can make linear dimensions. For example, if I want to get a linear dimension from the center of those cylinders, or circles, I should say. If I want to get, from line to line, plane to plane, that's how I make these dimensions. Now, what I just did is very quick and very easy. So in other software, I'd have to make 4 different planes or 4 different reference geometry to be able to do these dimensions. So even though it looks like I'm only doing one thing, if I turn on the mesh, the software is actually creating 2 dimensions and showing you all in real time what the deviation is for those dimensions. It's not just creating it on the CAD, it's actually inspecting it automatically while you do this. Just click, click, very easy. So I can do a radial dimension, I can do an angular dimension, and like I said, it's creating it on the CAD and also on the mesh automatically. So, okay. So that's that. I can create another group for like callouts. So for example, like if I want to do like flatness. So flatness doesn't require any datum. So I can say I want to measure the flatness of that top face. I can do that. If I want to like actually specify datum, like say I want to do like a true position, right? Like let's say I want to do the true position of this cylinder here, okay? I can tell the software I want to specify, I want it to be in relation to A, B, and C datums. So I can do that, and the software will give me, which by the way, I can modify those annotations any way I want. Right now they're like on a simple mode, but I can change my preset to like a detailed, and it'll show, the value, the measured value, the tolerance. I'm gonna leave it as just simple right now, but I can change all of that if I want to. For example, like let's say I want to change, let's say I want to check, or I want to check out perpendicularity of this top face here in comparison to my datum C. So the software will go ahead and measure that for me and give me the values there for it. So it's a very, very quick, very easy tool to use. And yeah, you would go ahead and add your dimensions. And the very last step is to go ahead and create a report. So that's very quick and very easy. You just click on Generate Report. And you can go ahead and type in your values. The whole inspection report that I was talking about, it's all there. And it's you know, kind of in the same order that you did it. But you can kind of move things around. You can put in your name so that the report has your name, the part number, the inspector number, whatever it is. You can type in that information here before you even make the report. And you can also add or remove anything you don't want. You can modify this and even add a 3D PDF page if you wanted to. So after you generate that, you get a report. You can have your company logo on there, name, and it'll show everything that you did. There's my initial alignment, my 3D compare, and everything is listed for you, all organized. So, and even color coded. So all of the dimensions and the points that I took, they're all listed there for me. There's my 2D compare, that 2D compare that I did. There it is. Those are the points compared to that. And you get values in relation to that. They're also color coded. My datums, I have a page there specifying what those are. And finally, I have my front view dimensions that I did earlier. And you can see that they're listed there, they're shown, and then they're also listed here, showing if they pass or fail. Obviously the green, you can, by the way, you can change that, like what you want the green to be, what you want the yellow to be, what you want the red to be. All of that is fully editable. But the intention of this software is for it to be very fast and very quick for you to go in there and do these measurements, and GD&T as well. And yeah, that concludes our session with Geomagic Design X for reverse engineering and Geomagic Control X for scan to inspection. All right, and with that, I'll turn it over to Tate and Tyler Reed.
All right. Welcome, everybody. We're here in Salt Lake City. This is our front office. I'm going to show off our Stratasys F370 system today. First of all, what I want to do is kind of explain the difference between this machine and some of the other machines on the market. We got hobby level systems, pro level or prosumer level systems, industrial systems, and then we have a production style system. And this system is really good at bridging the gap between a standard industrial system and a production level system. The F370 is our flagship model in the F123 series, and it really blurs the line between just an engineering grade industrial system and a production system. So it's really cool because it comes in at a far lower price point than a production level system, but it can do things that a production system can. So first I want to talk about the anatomy of this kind of printer and what it takes to kind of make it better than what's on the market. First thing is it's got a heated build chamber. So this system is completely sealed and insulated. So that's a big difference that's going to make it outpace hobby level system or prosumer level system is the enclosure that's built around this. It's not operating on a heated build tray. We're actually heating the entire chamber. So we actually have patented airflow, and what that is doing is giving a consistent temperature throughout the entire chamber. We also, like I mentioned before, it's sealed, and that protects us on the outside from excessive heat. So you can see we're here in an office style location. We don't have to have a special facility for a system like this. It keeps the heat inside, but it also keeps the moisture out. So another thing that we have is moisture sealed material bays, and I'll get into those a little bit later, but here are your 4 material bays. So the other difference on the inside of this machine is we have closed loop servo motors. And why that's important is because a lot of the industry uses an open loop stepper motor. And the difference between the two is that a stepper motor it gets told to go from A to B, and it tries. And sometimes it gets there and sometimes it doesn't, and it doesn't really know. A closed loop system, like a servo motor, tells it to go from A to B, and if it doesn't make it to B, it can do corrective positioning. So it can actually get to B, even if it didn't get there on the first attempt. Also, servo motors gives us precision control. So what that means for you guys is you're gonna have more precise parts, more reliable parts, and more repeatability. The other thing about this design, one, it just looks good, but two, the designers put a lot of work into making it user serviceable. So the major components like heads, we don't actually have to have a technician come and service the machine anymore. You can actually access it yourself. In fact, I'll show you guys real quick if you can see that. Stratasys, is it easier if I back it up? Yeah. These heads are actually toolless exchange. So I could change out one of these heads by just simply unclicking a cam lock, the ribbon cable, and the filament inlet, and I can change one of these heads out myself. So no longer the days of having a service technician to come to help me with that are gone. Also, again, it's very, very user-friendly. We have a touch screen here that's super responsive. It's going to tell me about my materials. I can pick jobs from the onboard system. But getting back to the inside, what makes this different is the ease of use. You can see we have this, again, in our office. So there are times when we have to call in and trust anybody to be able to come and change a job for us. With the touch screen and with how easy this system works, we can have anybody do this job. And you can see this tray has a bunch of hooks and loops on it. And that's actually what helps keep our builds flat. You can see that we've used this. They are reusable build sheets. We can do multiple builds on there. And like stated before, it's very intuitive. It lets you know when it's engaged and ready to roll. So that's kind of the anatomy and the buildup of what makes this system different. Now let me show you kind of some of the features. So as I kind of showed you before, we've got sealed material bays. So you have 2 for model material and 2 for support. We've got a little extra area here where we keep some gloves and some tools to clip filament. But loading material in this machine is actually very simple, and I wish I would have left one of these out to show you. But you just feed the filament into this hole, and the machine actually automatically will load that material for you. Again, these materials can be hydroscopic, so they're going to try and pull moisture from the air, and we want to make sure it doesn't do that. So Stratasys has gone through great lengths to make sure this is a good sealed system. You can see the build size. The build envelope's pretty large at 14 by 10 by 14. It's not the biggest on the market. There's prosumer level systems out there that are 2-3 times as big. The difference is going to be this heated build chamber. If you look at the build chambers on some of those systems, you can see that air is just leaking out everywhere. So they're not keeping moisture out and they're not keeping the heat in. So from there, what makes this system special is having 2 different advanced slicer softwares. You get GrabCAD Print that's feature-based. It works a lot like Solidworks or Creo, whatever you're used to modeling in. And then we have Insight, which is going to give you layer level control. And that's the same slicer that we use on our production level systems. So again, this bridges the gap between the 2. So lastly, I just want to go into materials and kind of some of the builds that we have on these. But the other great part about the F370 is it comes with 7 materials. You don't have to buy those packages like you do with some of the production level system. So you get PC ABS, ABS, ABS ESD7, which is an electrostatic dissipative material, ASA, PLA, Duran, and TPU. So you get some flexible materials in there. This machine can help you do a lot of things with that material flexibility. you guys want to come with me, I'll show you some of the builds that we've done. Here's one that just came off the machine not too long ago. You can see our support material there. It's water soluble, and it can be for something as simple. You know that this sprocket set's never going to be used on a bicycle because it's plastic. However, in prototyping stages, this could be extremely useful as a space claim. So this is something that I could have printed in a couple hours, designed and printed, throw it on a bike, get it ready for production. One of the parts I really like to show off is this intake. And this is our flexible TPU material. And you can see the finish on that is just spectacular. Even where the support material touched, it's really good, but really flexible. And the Z-layer adhesion is just spectacular. So that's another cool part. And these machines are really as powerful as you make them. So if you think about how it can help you hold on to components like this that are very organic shape. You can imagine trying to hold on to that if you had to do any post-process machining or anything like that. We can build fixtures that hold on to materials like that. It doesn't matter if it's an inspection fixture, a wear component on a machine that you have in-house, but really the sky's the limit. And you can see behind me a lot of the parts we have here are FDM parts. So with that, I guess we'll get to questions and stuff afterwards, but right now I want to throw it to Cameron. Follow me.
Okay, earlier I was able to show you guys the HandyScan Black Elite, which is a very accurate handheld laser scanner. Now I'm going to show the GoScan Spark, which is a handheld light scanner, sometimes called SLS, Structured Light Scanner. This scanner, if you look at the front of it, you can see has the cameras, and then it has a place where the light comes out. The light will put a pixelated patch of light over the part. As it's deformed, the cameras pick that up, and it's able to pick up the 3D scan. Some of the benefits of having a light scanner over a laser scanner are it's able to pick up color and texture. It's also able to do other scans as well, and so there could be a lot of crossover between the laser scanner and the light scanner. But the laser scanners do not pick up color and texture. So if you do want to do something where you're trying to recreate an object and get the color and texture, you're definitely going to want to use a structured light scanner like the GoScan Spark. What I have here in front of us is a little colored frog. And we're going to go ahead and 3D scan this frog. And then afterward, we're actually going to talk about how you might be able to then do a color 3D print of this. So you're going from, I have this part, I want to recreate it. Well, first let's scan it. Then we would take it, maybe do some cleanup on it in the Geomagic tools that William already showed. Once you have that final STL file, you can go ahead and send that right to a color 3D printer and get a color 3D print like this. So let's jump into the 3D scan. Again, I'm connected to my computer with a USB cable. Go ahead and start. And we'll go ahead and zoom again right here from the handheld. And as I work myself around this guy, I'm getting not only the scan data or maybe the engineering data, the size and shape, but I'm also getting a color map and a texture file So 3 files being connected all at once. Now, one thing you're going to want to watch when you're doing a scan like this is how much memory and how much RAM you have, because you can very quickly max those out, and if you do that, you can get a crash. So this is a big file that can be created. You can see I've got my hand in the scan there. Go ahead and stop this, and then we'll come over and we'll clean it up a little bit. Select our scan, inverse that to grab everything else and delete it. Look up here at the screen. Turn off the plane that I set so we weren't getting the table, that was the texture. You can see I'm getting the color and shape of this part. Now, we'll go ahead and say, let's finalize that scan. Take just a second. And it's the same thing as before. If we look at this underside of it, we see we don't have any data on that part of the scan. So we'll do the exact same thing we did before when we were doing the scan with the handy scan on the brake disc guard. Is we'll just come up and hit Add Scan, which will open us up a second scan in our feature tree. And then we'll go ahead and flip the Sprog over. Turn off our first scan so it's not in the way. And we'll scan in from this side. Now I don't have that flipping plane set up on this one. So again, what I can do is go ahead and set that plane up very quickly. Or there's another tool that works really quickly as well, which is this remove background tool, which is going to say, okay, I think that's the background. And then it actually lets me drag that up. So I can drag that right up to right below the table very quickly. So yeah, let's go ahead and do that. And that will basically delete everything below there, giving me just my part. We'll go in and scan him a little bit more and fill in the rest of that data. Now at this point, we're not capturing the table or any more of that extra data. Once we think we have everything we need, we'll go ahead and stop that. We'll clean that up real quickly again. Let me just delete that plane so that we can see him a little more clear. And you can see now we have the bottom of our frog, but not the top. So we'll do like we were talking before. Let's just finalize that guy real fast. And we'll come over here to merge scans. There's our 2 scans. Let's actually see if this one will put them together automatically, which a lot of times the software will do. It's exactly what we want to see, is those 2 kind of leading into each other. We'll go ahead and accept that and merge it. Turn off our first scan because our second one is the one we want to keep. We'll finalize that. And here you can see we have now a full color scan of this guy, top and bottom and all the way around. Now again, if you feel you need to add a 3rd scan, you can go ahead and do that and add a 3rd scan, 4th scan, whatever it takes. But again, we've shown how you can get a full color 3D scan, also getting the size and shape, and create a color map and a texture file to do things like a full color 3D print. The process from here is the same at this point. I'm going to go ahead and just go up to my file there and go export. This time it's going to export to default to an OBJ, which is still a mesh file that is able to accept that color and texture data. Now, let's go ahead and hand this over to Tyler Reed, who is going to talk to us a little bit about another one of our 3D printers.
All right. Thank you, Cameron. Even though I get to see that stuff every day, it's still magic to me. It's unbelievable how fast he was able to recreate the shape of that frog, but also the color data. That's nuts. Between those two scanners, the Handy Scan, the Black Elite, recreating ultra high precision engineering data, and the Spark creating high precision, but with color data, that's nuts. So I think I'm last up, and they say they always save the best for last. And this isn't a competition, but we follow that rule here. So I'm gonna be talking about the J55 PolyJet printer. The J55 PolyJet printer is the newest generation of printer that uses this technology that is owned by Stratasys. I'm going to briefly talk a little bit about how the technology works, and then mostly I'm just going to jump into some show and tell. There's a reason why we brought this technology after the color scanning, which we'll talk about. Your printer at home. You take a beautiful photo, you want to put it up on your wall, you load cyan, yellow, magenta inks into your 2D printer, you hit print, it creates it. Very easy, very simple. We all know how to load a printer, print a picture. This printer essentially does that, but it adds a third dimension, that 3D space. So we're able to load up this printer with a variety of resin materials. Down here, you see 12 slots. Those slots right now are filled with a yellow, a cyan, a magenta, and a white material, and then one more material that we kind of pick and choose what we want. And in this case right now we have clear. So we have a full color spectrum plus a clear material. Just like your 2D printer, we can mix these on the fly. As we're laying them down, we hit them with UV light that cures the resin and creates a solid part. So your 2D printer at home, you load up 3 materials and it can create millions of colors. Similar to this scenario here, we load up some base resins, we can create hundreds of thousands of unique colors. The OBJ file that came out of Cameron's scan gets loaded up into our software straight away. OBJ file, 3MF file, VRML file, and we can print. In fact, this frog that we scanned was printed. That's a 3D print. So this is printed in matte finish. We also have what's called a gloss finish, which gives you that very glossy texture. Now, it's easy. We have a lot of flexibility in what we're going to do. Let me talk a little bit specifically about this machine. This machine was designed for designers, okay? Just like we had the 370 there in the office, this is designed to be printing in an office environment. We have the luxury of having a lab, not necessary here. Nearly silent operation, odor-free operation, and it doesn't take up a lot of space. So something that we've always struggled with 3D printers is the balance between printable area versus the footprint of the machine. And this system is designed in such a way that that ratio is unheard of. They did it by basically reinventing the linear system on this. There is no linear system on this. On the F370, you have an XY gantry and you have a Z. On this, you actually have a donut-shaped build envelope. So we open this up and you zoom in a little bit here. This is the process or the movement that's happening while the prints are happening. So we're printing in this sort of donut shape, and that donut moves down in Z. The print head sits up here at the top. That print head is not moving while printing is happening. So we actually have much fewer moving components, and for all the engineers and designers here on this session, you guys know fewer components means less maintenance, less wear and tear, and less source of error. So we're getting prints of this system that are just, they're beautiful. They look like they're injection molded parts. You cannot see layer lines. You get these beautiful colors flowing into one another. And it all has to do with Stratasys' leap of faith that they could redesign how these systems are printing. I'm going to show a little bit more show and tell. So I'm going to show a variety of parts. And I want you guys to be thinking about maybe some use cases for these parts. So I brought this part up because it displays just how intricate of a part you can create. The geometry doesn't matter. So just like a 2D photo, if you're going to be printing a cartoon that's 3 colors versus printing a beautiful portrait with millions of colors, the effort on your side is pretty much the same. Same goes for this. Throw as many colors as you want, throw whatever geometry you want at it, you hit print, you walk away, it comes back. This print here came off the J55. So this was an artistic piece that I really didn't want to be confined in my design to what is manufacturable. That's something that we're always up against. Now in the prototyping phase, you never want to have those chains on you. You want to be able to prototype whatever you want, exactly how you want to do it. And this is a perfect example of that. If I had to take this to conventional manufacturing, it's going to be redesigned. I'm going to have to make concessions in what I want to achieve with my model. With printing, especially in the prototyping phase, I shouldn't have to go through those hurdles. It doesn't make any sense. It adds cost, it adds time, and we're all on a budget with both of those. And so your prototyping should be as easy as possible. Prototyping sometimes is single material. Sometimes it's multiple materials. Sometimes you don't even know what materials you're after. On these printers, in the PolyJet printer, we can do hard materials, we can do soft materials. We can mix them at different ratios to achieve whatever durometer or softness that we want. Sometimes we don't know. So if we're prototyping and we have a series of buttons in our device, say it's a handheld device, we want to know for the market that we're intending, what's the right softness for the button? How do you do that? Conventional prototyping, you're going to have to cast all sorts of different levels of durometers. It's very time intensive. On a printer, you just set the durometer and you print as many as you want. Sometimes in the prototyping phase, we're trying to determine color, we're trying to determine material, and we're trying to determine finish. With these printers, we're able to replicate things like carbon fiber, wood grain, denim. I'm not designing a lot of things in a denim finish, but maybe some of you are. And we can print these high fidelity models. So you get a model like this, and you bring that to a meeting with a C-level executive or a potential buyer, and you say, this is our design. It's been vetted. We've gone through many prototypes. We feel good about this. How do you feel about it? And the level of communication that you're going to have with a model like this in your hand is light years above a render or something made out of cardstock or paper or what have you. Conventional prototyping efforts. Now think about items like packaging. If cosmetics and many, many other industries are all about packaging and color. Color is part of their brand. And if you don't have the right color, you're not representing the brand properly. The J55 and our other PolyJet color printers are all Pantone validated. So inside the software, if we're trying to target certain colors, we're speaking the language of color, Pantone. We have Pantones, we select them, and they come out exactly how we are envisioning. This has some translucency to it. That's where that clear material comes into play. This, I guarantee, if I handed this to you, you would be so confused because once it touches your hand, Cameron, we need to give Cameron some lessons on this camera. Once you hold it in your hand, you're confused because from 2 feet away, your senses are telling you this is glass and this has nail polish in it. But once it's in your hand, it doesn't have the weight of glass. It doesn't have the feel of glass. It's all about the appearance, and it blows my mind every time. Couple other things, just real quick. This is another scan. The beauty of scanning something is that it becomes digitized. and we can blow it up, we can scale it down, we can modify it, we can design around it. This was step one in a process where we were basically doing the most expensive jack-o'-lantern carving ever. But step number one was scanning that pumpkin. It's unique. There's nothing like it. And there's so many things out there in the industry that are unique that you have to made up, or unique and you have to verify. That's all about what scanning is. And in some cases, the workflow would require you to come to print it. In other cases, the workflow may not. Lots of different workflows. I'm gonna show you guys a couple more parts and then we'll call it good and open it up to questions. I did talk about that gloss finish. Here's another example of that frog. And I'm just gonna kind of wave it here. You can see the light shining off that. That's straight off the, not straight off the printer. It has support material we remove. It's a 1 minute process. Other than that, there's no clear coat on this. There's no sanding. There's nothing like that. It's just right off the printer. Very high fidelity models. If you're looking for high fidelity prototypes that are very simple process to create, you create dozens of them overnight. This is a perfect technology for you. Again, mimicking soft goods. I wish this was real because I haven't eaten today. This one's better. I like my Twix. These are 3D printed. Cool stuff. Very cool stuff. It looks like Chris has been answering your questions as we go, but that's all I have for the PolyJet technology. We have tons of resources on our YouTube page, just youtube.com/GoEngineer. GoEngineer.com has tons of resources as well, and we'd be happy to follow up on any of these discussions personally. But I'd say, Chris, we got questions?
Yeah, we've been going through and answering a lot of these on the chat. I think we're up to date.
All right. Let's see. Did we talk about the build volume of the J55? Did you answer that?
I did. I talked about the volume. There's one question on there regarding dimensions of the printable volume.
All right. So let me talk a little bit about that. I talked about the build volume being very high for the footprint of the machine. That's because you have this big donut shape in a tight square. So the machine itself is about 24 inches by 24 inches. That's the footprint. The donut has an outside diameter of 18 inches. There is an inner diameter that you can't print on. That's about 4.72 inches, give or take, 4.72 inches, 120 millimeters. So you have 18 minus 4, that gives you a radius of a little over like 6.5 inches around the build tray. Ideally, you're printing parts that are about fist size or smaller, and many of those parts, but you can fit long parts. So if you had a wrench, for example, you could fit a 17-inch long wrench. The build height is 7.3 inches high.
Are there tutorials?
Yeah, so, okay. Are there tutorials for creating high fidelity color models and textures? There are. Like I said, we can take on a lot of different types of models. So the workflow is going to look different for every single person on this call. If you are a character designer and you're programming or designing parts in Maya or Blender, we can take OBJs out of that. If you're a CAD designer and you're doing your models in Solidworks, you can put your textures, your appearances in your Solidworks model, export a 3MF file, and we can open that up. You can do some color applications right in the print software as well, but you're not going to be doing the photorealistic color textures. You're just going to be assigning different colors to different bodies or faces on the model. All right. Questions. Will the HandyScan work with Creo?
Well, again, I don't know a lot about Creo because we're a SolidWorks reseller, but the main export off the 3D scanners is a mesh file, so a .stl or a .obj. SolidWorks has some ability to open those, but not really work with them. Creo, on the other hand, I don't know what its ability is to work with an STL or an OBJ, so you want to check that out. But if you go through GeoMagick, and so you take that scan into GeoMagick, GeoMagick does have native exports for Creo. And so that's where you're going to go ahead and take that scan from SCAN and change it into CAD. So what you're exporting from Geomagic is actually CAD. It's not a scan. So it would be like a .stl, a step file or an IGES file or even a native Creo file.
All right. So the question is, what does the J55 use for the support material and how is it removed? Let's give me like 1 minute and I'll show you. All right, we're going mobile. So the PolyJet system uses a wax-like material for support. So potentially we have a part with support on here. We don't really have a part with support. Don't worry about it. We don't really have a part with support, but the way we remove the support is one of two methods. Method number one is we use this sort of benchtop water blasting station. It works a lot like a sandblaster, but it's shooting water, all right? So it's all self-contained. This closes up. Put our hands in the gloves, we shoot it off. That gets these parts cleaned within like a minute or so. The other type of support material that we have is water soluble. So we just put it in this tank. The tank heats up, it agitates the water a little bit, and that's a hands-off method of removing the support material. Might take a little bit longer. You know, for some parts, it might take 30 minutes, an hour, 2 hours, it just depends, but it's hands-off. So we have two options on the PolyJet side. All good. All right, that's a big question. Robotics engineer from the Philippines. Here's my questions. How cost effective are the 3D scanners with the Geomagic softwares compared to when hiring a person to do the manual measuring of a component? That's tough to say, especially if you're coming from the Philippines. I think the market for your work there in the Philippines would be much different than here in North America. But that's an ROI that we could help calculate for anybody that's interested. You guys are trying to get away from the camera, huh? Let's see, what build software does the J55 run from? It's GrabCAD Print. GrabCAD Print is what powers all of the latest generation of Stratasys machines, FDM, PolyJet, yeah, all GrabCAD Print. Yeah, it is. It's good. It's a very good software. By the way, if Tate was able to find a part with the support material on it, it's going to be really blown out here, but here we go. You can see it's just kind of waxy, and I can tear it off with my fingers. So there's no, once you remove the support, that's it. There's no other steps. You just got to get that support off either manually or just let it dissolve away. But there's no post curing. There's no soaking in a solvent and nothing like that. Let's see. So following up on the glass question, can the J55 mix color and clear to create smooth, transparent glass? Well, it can create glass-like materials, and yes, it can tint those colors. So, you know, you have some base resins that actually have a little bit of transparency to them, and you have a perfectly clear. You mix them at almost infinite number of ratios, you're going to get transparent or tinted prints. Loving these questions. And I'm so happy to see that so many of you stuck with us for the 90 minutes. This is something a little bit new for us. We love doing show and tell, and it's not very often we get to tag team and show all of our cards all at once. It's been kind of nice.
Yeah, and we're actually 15 minutes under time. So
Cool. Very cool.
Went through it really good. Just really quick and efficient. So thank you guys.
Yep. Paula, Chris can help you with that question. And Michelangelo, how's the average printing time for the Stratasys compared to cheaper printers on the market? I'm not going to really be able to say because I'm not familiar with the print times of those. And we do have a variety of print methods and print times here in the Stratasys lineup as well. And it's even really hard for me to compare FDM versus PolyJet. They scale differently. But one thing that you're really going to see a difference in is the post-processing time. Stratasys has put so much effort, honestly guys, years and thousands of hours into R&D to make the printing experience as simple as possible. And the printing experience doesn't end when you take the part off the tray. The printing experience ends when you have a viable part ready to show your customer or your partner, your business partner, what have you. And there's multiple steps in that. Stratasys really shines in the lack of post-processing needed, lack of labor, lack of time involved in that.
I did.
No reprints.
Yeah.
We don't have the reprint parts. That's something that gets lost on all the time. If you print a part and it's bad and you have to print it again and it's bad, what's your print time?
Yeah.
Is it 1 hour or is it 3 hours?
I just got feedback from one of our current customers. They have one of the older Dimension printers, and they're looking to take advantage of the trade-in and upgrade to the Stratasys F370. They were also looking at a couple different hobby printers. The feedback that they told us was the F370 printed the exact same part roughly 4 times quicker than a variety of the hobby printers. So 4 times quicker. I asked about the quality. They're like definitely several notches up in the quality. So it was good feedback. So that was their parts. Every part's different, like Tyler said, but I thought that was pretty interesting. Still got about 51 participants. So one thing we will get, so everybody who participated, we'll see a list of the participants. We can email you guys. So if you've got any direct questions that you want to ask the application engineers, let us know, and I can loop you guys in and ask questions. If you want to see a custom scanning demo, we've offered that as well, where we've scanned parts similar to what our customers have, or even in some cases they've mailed the part to us. We've scanned it, showed that via live. Benchmark parts. If you want to send us a file, we can do some prints on the J55 or the 370. So yeah, here to help. So whatever we can do, we are available.
All right. Is that it? Are we signing off?
I think we're signing off. That was everybody. So
cool.
Here's contact info. That's it.
Thank you. I appreciate
All right.
it.
All right, guys. Have a good one.
Thank you, everyone, for attending.
Ma'am.
Have a great rest of your day.